One of the ways you can use a view is to pre-format data. Essentially take data out of a table, one or more tables, and then put it in a specific format that you need. So this first example creates a single column called address with an employee's name and address listed the way it would be on an address label. All right, so we have create view. Keep in mind again that we're creating a persistent database object. So when I execute this code, it's going to create the object, but not execute the view code. All right, just going to use the default DBO as the schema and call it employee address labels. And then the select statement is going to select the first name, add a space between it, and last name. Put in a carriage return line feed. Output the address, another carriage return line feed. And then the city. And then it'll use a case statement in order to handle the case that region might be null. If region is null, it just puts in a space. If region's not null, then it puts in a comma, space, outputs the region name, and then a space after it, and then another carriage return line feed and the country. All right, so first thing I need to do is execute this so that it's in the database. Execute it successfully. And here's how you can then test that view. So I'm going to select address from that view. So here's where you can see that using a view is pretty much exactly the same as using a table. So I'm going to use a select statement, and the from is the view. The view is going to return information from the table, in this case just a single table, the employees table. And in this case, I'm requesting the single column that's returned by the view. But I can return in the select statement as many or as few of the columns from that view as I want. So now when I execute this code, you can see the output that we get. And this is one that doesn't really show what it's doing using the results to grid. So what I'll do instead is I'll right-click here. Oh, and actually I need to do that in the query window. And select results to text, and then execute it again. And now you can see, if I scroll back up here to the top, we have this formatted address. First and last name is on one line, the address, the apartment, Seattle, Washington, and so forth. And so, in theory, these are now formatted that you could output this directly to a set of address labels. Now, in the real world, you'd probably want some additional spaces between them and so forth, but you have the tools that you need in order to be able to format that information and output it, say, to a text file. Okay, so that's the first view. Before I forget, I'm going to change the results back to grid, because most of the time that's a better way of viewing the results of queries. And I'll hit Control-R to close the results window. All right, so here's another example of a view. So another use for views is to take complex analysis and simplify it for users. So what this view is doing is it's going to calculate the best customers in the Northwind database by the number of orders. Okay, so that's one of many criteria that we can use to define our best customers. So the nice thing about using a view to do this is that the results are always current. Every time you access this view, it's going to go out to the underlying tables and get the current information. So if I run it now and then go in and add a bunch of new orders for customers and then run or access the data from this view again, it's going to return, that second time, it's going to return the updated information. And the list of our best customers may change as a result of those new orders. Okay, so once again, it uses the create view. In this case, it's going to be called customers top 10. And it's going to select using the top statement, the top 10 records, and I'm going to include ties. So if there's any number of orders, any customers with number of orders that would tie, I'm going to get all of the customers with those ties at the 10th position. Okay, and I'm going to return the customer ID, the company name, and then count as number of orders. And so the main information is coming from the customers table, but I'm joining in on the orders table and using the customer ID value as the linking column. So I have an aggregate within the select statement, so I have to follow all the normal rules of select statements. So I need to group by customer ID and company name. So this is going to group the set of orders by the customer. And then I'm going to order it by the number of orders in descending order. And so that, combined with the top statement, is what's going to return to me our best customers, again, as defined by the number of orders. All right, so I'll create the view. It now exists within the database. And then I can test it using a select statement like this. And I'll execute that. And as you can see, we get a total of 12 customers back. But the reason we got 12 is that we have 3 that have 15 orders. And so because I included with ties, I got all 3 of those. If I didn't include with ties, this clause right there, then it just would have given me randomly one of those 3 customers, and I only would have gotten 10 results. And so this shows one of the benefits of using views. This is a really simple select statement. In fact, made it a little bit more complex because I'm including this order by clause there. But rather than having to write out all of this code every time I wanted to create a select statement, I can just access the view, and it has encapsulated within it the logic for creating that list of top best customers. Okay, here's another example. So another way to use views is to encapsulate complex joins and subqueries. So this query here, this order low prices, reports on any orders that contain line items with a cost of less than $3. So we just want to find all of the orders that have very inexpensive items to them. So this view uses a select statement, as usual, but it uses this subquery, and in fact it's a correlated subquery, in order to compute the results that we want. All right, so the way this works is that I want to select information from the orders table as order, as O, where the orders exist within this correlated subquery. So the correlated subquery, it's called a correlated subquery because I'm using information. I'm actually accessing each of the rows within the order table there in order to filter the results of this subquery. So I'm selecting the order ID because I want to check to make sure that the order ID from this outer query is contained, with using this exists keyword, is contained in the results of this correlated subquery. So I'm going to select the order ID from order details, match on the order ID, and then filter it in some way. And in this case, where the unit price is less than $3. So I'll create the view and then test it. And now that gives me a list. There's 32 orders altogether that have line items with a price of less than $3. Now you can create that same view using a join rather than a subquery. So here's an example of that. A little bit simpler notation, but sometimes you have to use subqueries in order to create the logic that you want. But you can also use an inner join here. So it's retrieving the information from the orders, joining on order details, and then filtering on unit price. So that's just a variation of the previous view, showing that you can use different techniques in order to return the same information. As you can see, we get the same 32 rows back from the view. So this kind of a view is useful if, say, your company has a business rule that forbids discounts on products with prices under $3. You can use this view to check for any products within that special category, and if the rule changes, you can make the change in one place in the definition of this view, this magic number that's defined here, without affecting any other code that calls this view. So again, it's a way of encapsulating business rules within your organization. Now we're going to ratchet up the complexity a little bit. You can create views that select data from other views. And this is sometimes referred to as nested views. And the nice thing about nested views is that you can use them as an alternative to derived tables. So that's just one way. But as a practical matter, what you can do is you can break down any kind of complex select statement into component parts using multiple views, nesting them, and then executing them all as a whole in order to retrieve the results that you want. So in essence, what you're doing is you're breaking down a complex problem and making it simpler by creating component parts. And then you can also use the individual component parts on their own. So let's see how this works. First, I want to show you a select statement that uses a derived table. All right, so what I'm going to do here is I want to display a list of Northwind products, the unit price for each, and the average price for products in that category. So I'm going to select the product name, unit price, the derived average price, and the category name from products, and then join on this derived table that is defined here within the parentheses. And I'm also giving it the alias name derived. Nothing magical about that name. It just identifies that it's a derived table. So here what this inner select statement is doing that defines the derived table is selecting the category ID, calculating the average price, and grouping them together by the category ID. So that's one of many ways of calculating the average price. All right, then, so I use that, I'm joining that to the products table, and then also joining it on the categories table in order to be able to get the category name. And then I'm ordering things by the unit price in descending order. All right, this isn't a view, but it shows the results that we want to achieve. So again, list of products, unit price for each, average price for products in that category, and providing the category name. Okay, so a little bit of complex logic, not overwhelming, but you can imagine that this kind of a query can very quickly get far more complex. Okay, so I'll close the results window, and here are a couple views that replace that derived table, or replace that select statement. And the first one replaces the derived table. So it's extracting the logic that calculates that unit price out into its own view. And then it's going to use that view within another view, and there's that nested view right there, in order to essentially encapsulate all of the logic from the select statement outside of the derived table. So again, breaking down the logic into its component parts. Okay, so I need to create these views. And then contest it using that select statement right there. As you can see, we get the same results, but we've broken the problem down into manageable chunks. So overall, using the views, you end up with a few more lines of code. But each section, each part, each component stands alone, and the overall query is easier to understand. And anytime a query is easier to understand, it's far more maintainable, particularly for people that come after you that have to maintain this code. And another side benefit is that sometimes the query analyzer can come up with a better execution plan when you break things down like this. Not always. And the query execution engine gets better and better with each new release of SQL Server, but sometimes that's a benefit. But you would need to check and look at the execution plans in order to make sure that that's actually happening in a particular case. In the context of views, I want to talk very briefly about common table expressions. A common table expression is a kind of temporary result set that's defined within the execution scope of a single select, insert, update, delete, or create view statement. So a CTE is similar to a derived table in that it's not stored as an object and lasts only for the duration of the query. But unlike a derived table, a CTE can be correlated with the outer query. It can be self-referencing and can be referenced multiple times in the same query. So common table expressions are just much more flexible than derived tables. So a common use for CTEs is for creating recursive queries against hierarchical data, or for grouping by columns derived from the results of a subselect or a non-deterministic function. because a CTE can reference the resulting table multiple times in the same statement. So it's kind of a weird concept to talk about, but once you really learn about how common table expressions work, they can simplify complex queries quite a bit. Although CTEs tend to be more complex, but it's only because they tend to handle more complex problems. So let's take a look at an example of a common table expression. Here's some code that shows how you can use a common table expression in order to replace that previous query that I showed you, the one that calculates the average prices of categories and then uses it within a select statement. So the way you define it, not to dwell on the syntax too much, is with the with keyword here. This is the name of the common table expression, and you can specify the columns that are returned by the common table expression. And then I just have that select statement that calculates the average price, average unit price, of products of a particular category. Okay, so that's the derived table from the previous query. And then I use that common table expression within a select statement here. I'm going to select from products as I did before, and then join on that common table expression. So this code returns a table. I can use it multiple times within a statement here. And so I'm joining it to products, and then also joining on categories again. So this logic is the same as the previous query that I showed you, but using a common table expression instead. And it's important to understand that the common table expression is not a persistent database object. This is going to exist only in memory during the execution of this overall statement. And as you can see, you get the same results down here as the previous query. You can also encrypt the definition of a view and still use the view as you would any other view. In order to do that, all you have to do is add the with encryption clause to the view definition. So it's a very simple way of preventing users from casually being able to look at the source code of your view definitions, because views can encapsulate some complex code that you might want to protect from prying eyes. Here's an example of creating a view with encryption. The only difference here is that I've included this with encryption clause. Otherwise, the view is pretty straightforward. So I'll go ahead and create that view. Switch over to the Northwind database here and execute it. And so now the view exists within the database. And then I can use it normally. There's nothing changed about how I use the view in order to extract data. There's no additional security or anything like that. SQL Server understands how to extract the view definition and be able to execute the view. So everything up to now is pretty much normal. But now if I try to use the system stored procedure help text in order to view the transact SQL, all I get is this message saying the text for object dbo.encrypted is encrypted. So it can't return the T-SQL that was used to create that view. But just to show you what that system stored procedure does, if I use it on a non-encrypted view, this is that employee address labels view that I created earlier, I'll execute that, and as you can see, you get each line of the view definition returned within a result set. And you can see the code that was used to create the view. All right, so that's what encryption does. Now, SQL Server 2005, way back in 2005, introduced a new function called object definition. This provides an alternative to using SP help text. So in this case, if I execute that function against an encrypted view, it returns null instead of that message. Otherwise, if I run it against an unencrypted view, it returns the view as a single statement. And in fact, if I change this to send the results to text and execute that statement again, you get something that looks much more like the original view definition, complete with white space and line breaks and so forth.